Hello everyone. Thank you for joining us today. Thank you for jumping through the hoops to join us today. We're here to discuss driving manufacturing performance with AI video analytics. Along with me today, I'm joined by Carl Van Dommelen of Foxconn IAI. Next slide, Carl. My name is Tim Stewart. I'm the founder and president of Visual Decisions. We are a services and solutions provider to manufacturing companies. We've been helping our customers combine the smart factory and the lean factory since 2002. In addition to working with companies across virtually every manufacturing sector, we also work with groups like SESME to define standards for American manufacturing. For those of you who have not heard of it, SESME is the official USA Smart Manufacturing Institute funded by the Department of Energy as part of their overall Manufacturing USA initiative. One such effort that we have underway with SESME is to create the standard training material for digital lean. Over much of the past 22 years, we at VDI have focused on collecting machine data through sensors, PLC connectivity, and more. We've helped customers make a tremendous use out of this information to drive improvements in their performance. But acquiring good data for manual operations has been much more difficult, but no less important. In order to address those parts of manufacturing operations, we've been looking for a world-class solution that would help automate the data capture and analysis process as much as possible. So to that end, we are partnering with Foxconn to fill that gap in our toolkit so that we can provide those capabilities for manual processes to manufacturing companies. From our perspective, there's no better solution on the market than AI video analytics to understand and improve the performance of manual operations. And I don't want to steal all of Carl's content, but to us, the Optimo solution helps us to identify and eliminate sources of process variability, which leads to better quality and higher throughput. Perform continuous time studies across operation steps, which can help balance lines more effectively to reduce costs and increase output. And provide traceability to identify special causes of variation so that steps can be taken to remediate existing issues and prevent future occurrences. And really much more than that. Overall, it's an extremely powerful tool to address manual manufacturing challenges. Just a quick note, please add any questions or comments into the section on LinkedIn or here on Zoom, and we'll circle around and answer those after the presentation. And we'll also be posting contact information for both Carl and myself everywhere as well. So with that said, let me turn things over to Carl to talk in more detail about Foxconn and the Optimo solution.
Okay, very good. Thanks, Tim, for the introduction, and more importantly, thank you all for attending. We're super excited about really the great response we received for this webinar. So, well, hey, let's dive right in. As Tim mentioned, my name is Carl Van Dommelen. I head up Foxconn IAI sales group, and we're a very, very small group inside of a very, very large organization. For those of you not familiar with Foxconn, let me just give you a few quick facts, a quick overview about the company. We're essentially a worldwide organization and are the largest electronics and contract manufacturer in the world. Our biggest claim to fame is that we assemble all of the iPhones and iPads for Apple, along with several other devices like gaming systems, printers, and consumer electronics. We're also in several other industries such as medical devices and electric vehicles. The important or salient point here is with over 700,000 people, most of whom are on our factory floors, this means we have direct access to one of the largest sources of human motion in manufacturing. And I'll talk a little bit more about this later when we dive into the AI video analytics. But moving ahead, real quickly, Foxconn is following what we call our 3+3 strategy. And this is really pursuing three specific markets with three specific technologies, those being robotics, digital health, and electric vehicles. Next generation technologies such as communications, semiconductors, and last but definitely not least, artificial intelligence. And that's where our group comes in. So our group was formed about 5 years ago and is made up of data scientists, industrial engineers, AI experts, and software programmers. We were brought together in an effort to look at and improve our own internal manufacturing processes and increase efficiency by applying new technologies and methods. We started in earnest to develop solutions around 2020, and in 2021, we actually implemented a few of our solutions or a few of the developments into select factories, both locally and overseas. We saw such good success with Optimo, which is the software package I'll be showing to you a little bit later, in mid-22. And because it was such a success, we decided to market it outside of Foxconn. After all, who doesn't want to make more money, right? Anyway, since then, we attended and exhibited at a few trade shows, and this year we partnered up with Visual Decisions. So enough of the history, let's get into the good stuff, huh? Foxconn itself spends millions of dollars every year on automation and specialized equipment, but we realized and recognized that there are still a number of manufacturing and assembly tasks that we perform manually. The challenge then is, how do we get more out of and optimize our current workforce? To improve performance, you need data. It's easy to get data out of a machine, such as a PLC or a dedicated piece of equipment, but it's a much more complicated task to get data out of a person. This is where time and motion studies play a pivotal role. Just about every industrial or process engineer agrees that time studies are a valuable tool and that they should be performed more often or more frequently than they are. However, traditionally, they tend to be tedious, time-consuming, often expensive if you're using an outside firm, and more importantly, they only give you a snapshot of how your production operation is performing at that particular time in which the time study is being conducted. So as a result, we set about trying to improve the process of conducting a time study, and the journey goes something like this. Initially, we were presented with the challenge, like I said, how do we get more out of our current workforce, with the end goal being faster throughput, improved quality, and lower cost. To do that, we were also given a list of requirements. Ultimately, with any tool, it has to be easy to use. In our particular case with time studies, we wanted ultimately to collect more data. Instead of, like I said, just a snapshot, we wanted to get a full picture of our production lines, our production facility, and really see how they were operating. The last two requirements, use off-the-shelf hardware wherever possible, and low cost, of course. We wanted this tool to be available to a multitude of our factories and installations. And obviously, if it costs too much money, budgets come into play and it becomes an issue. Ultimately, the solution that we came up with was using AI and video analytics software. And this was primarily a result of looking at collecting more data. Okay, you may ask, why did you go with AI? Well, firstly, it was to automate the process, because especially if you're an industrial engineer or a process engineer, who wants to sift through hours of video, right, to look for, say, an anomaly or an incident. Secondly, we also needed help dealing with or diving into the large amount of data that we would be generating using video capture and video analytics. So that was really the solution. And ultimately, what we came up with was Optimo. Drum roll, please. Optimo is the name that we actually gave to the software solution. And when we started marketing it outside, we use this as a way to give it a brand name and so forth. And it's one of the few, if not only, Foxconn branded products that's out in the market today. So with that, we discovered a few things. I'm going to step back a little bit and do a comparison between, traditional way of doing things, the solution we came up with, and more importantly, the advantages we saw with that solution. I like to call it the bonus or the extras. Like I'd mentioned before, traditional time studies, they were offline, labor intensive. You had observation bias. Anybody that's conducted a time study has, experienced this, where if you're standing over an operator's shoulder or watching him, you do affect their performance. And we've seen it go both ways. Sometimes they work slower, sometimes they work faster. So we were really looking at methods and ways with which we could either eliminate or reduce that bias or that effect. And what we realized is, by using off-the-shelf like web camera or IP camera, after about the first day or two, the operators really didn't even notice it was there. There's no indication that it's recording or what have you. And when we explain to them that we're really just interested in the motions that they're performing with respect to the workpiece, it becomes a non-issue. Moreover, what it really allows us to do is it allows us to get or capture video information 24/7. All 3 shifts, day in, day out, and do this, in kind of a hands-free environment. So now by setting up a solution like this, what we've allowed industrial engineers and process engineers to really conduct a time study remotely, which is a big savings, because eventually and ultimately, if you're embarking on and working with continuous improvement initiatives, the whole point is you've got to keep checking and rechecking your assumptions and any changes that you make. And this is where video analytics, AI video analytics really come into the fore, because now what we've done, and as our own experience has shown us, we've moved from a measurement tool to a management tool. And this goes beyond traditional time studies. So this has allowed us to make data-driven decisions to reduce cycle time, reduce variability, refine our process, but more importantly, once we make a change, we can test that change or test those assumptions out to make sure that it had the net effect that we at least desired it to, and really see if any changes that we make, really were effective. Similarly, we also have, or what this allows us to do is have video traceability. So we can do incident reporting and root cause analysis. And what this has really opened our eyes to do is a lot of times, or oftentimes, we can look at process drift. Since we're collecting data over time, this allows us to see how our production line and our production facilities are running. Are they running consistently? Are they affected by, seasonally, or, through really shift 1, shift 2? Do we need to schedule breaks earlier or later? It's really given us a really good insight into our own manufacturing processes, and for those of our customers that we've implemented the solution with. So what does this allow you to do? Well, at its very core and its very root, by collecting this much information and really being able to process it almost instantly, we're able to look at individual operator performance. We can compare operator to operator, line to line. But more importantly, what this tool also allows us to do is really provide a feedback loop such that we can, for the most part, assure adherence to standard work. I can't tell you how many times we've met with production folks who've said to us, if I could just get my operators to follow the SOP, I would eliminate 90% of all of the problems that I have in my factory. This tool allows you to do it, because what it really is doing is it's looking at the execution of that SOP step by step, and also making sure that you hit your cycle time targets. And then, like I had mentioned previously, we can identify trends and process drifts. So when we set about designing Optimo, our whole point was to make the process as simple as possible. So we boil it down to 5 basic steps: recording video, annotating steps, training the AI model, inferencing, which I'll explain in a little bit, and then finally analyzing the data. Recording the video is actually quite simple. In our particular case, and being an electronics manufacturer, we designed it to pretty much work at a workstation looking at a single operator. In this particular case, this operation is just printing out a barcode label, applying it to a carrier in which a motherboard is installed. The key here is really proper camera setup. So it's a fixed camera, either web or IP camera. And the critical thing to note here is what you want to do is get a very clear picture of the operator and how their limbs and upper arms, or upper body, interact with the workpiece. Once we feel like we have a good camera angle and a good view of the operator, or a clear view of the operator in the workpiece, and have recorded our video, we go about doing what we call annotation. Now, this is the step where your process engineer or your industrial engineer will be interacting with the software the most. And this is where we actually have the user or the operator identify the beginning and end of each individual step in the SOP. For Optimo to work properly, we require a minimum of 5 cycles, 5 complete cycles, and you annotate each one of those cycles. And really what you're doing is you're providing a template to the AI engine so that it will recognize each individual step discretely and distinctly from each other. Obviously, the more steps or the more cycles you have, the better the training of the algorithm goes. And we'll show you that in just a moment. To give you an idea of how the algorithm works, after you've annotated the video, you just hit train, and the AI engine goes about looking at the template or the annotated video that you've submitted, and basically it learns what the operator is doing at each individual step and learns to identify that step with respect to all of the other steps. In the display I have here, this isn't exactly how it works. This was an ergonomic module we were testing back about a year or so ago, but it gives you an idea of how we track the motion of the operator as she interacts with the actual motherboard or with the actual workpiece. So ultimately, what you're doing is you're setting up a template for the AI engine to learn. Once the AI engine has trained the model or created the model based upon the annotated video, it generates a confusion matrix. I like to call this a confidence score, but basically what this means, and this is a numerical representation of how well the AI engine learns or recognizes the individual steps in an SOP. So on the y-axis, you're looking at what we call the true label. This is what you actually annotated. On the x-axis, this is the predicted label, and this is the result that the AI engine produces based upon what it learned on that annotated video. So if I can draw your attention to the lower left-hand corner, we have 2 steps: apply barcode and insert screws. 83, and what this chart is basically telling us is 83% of the time, the AI engine gets it right. It identifies the apply barcode step as apply barcode. But 17% of the time, it mistakes it for the insert screw step. So what would we want to do here? We would want to refine that process by feeding it more video. Again, like I mentioned before, the more information you feed it or give it and examples that you give it, the more robust the algorithm becomes and the better it executes, essentially measuring cycle time of each individual step. And then last, but definitely not least, we analyze the data. So the beauty of a tool like this is you get this information almost immediately. In the case of real-time inferencing, which I'll show you in just a second, we can do this pretty much on the fly as it's happening. This requires a local solution, but I'll talk about that more in just a moment. The real focus here really is to drive decisions based upon data in real time. So in so doing, by producing or basically monitoring your production process, you're able to affect change very, very quickly, identify problems, do root cause analysis, and ultimately display that information quickly so that someone can make a decision or take corrective action. And I'll just step through the charts here fairly quickly. We have multiple analyses available. Standard which a timeline or a bar chart will just give you individual cycle times for each of the steps in the SOP. And this is really to look at frequency and duration during the assembly process. Next, we can also do Pareto analysis, and this really identifies the bottlenecks in your operation. In this particular case, and in our particular case, if you notice, the process that had the longest amount of time was the attached label process and not others. Others we define as non-value added. What this prompted us to do was actually look at that particular station, move the barcode printer and the scanner closer to the operator, and we were able to reduce the cycle time very, very quickly with this. But we didn't know that this was a bottleneck step until we actually did the analysis. So this is a very, very useful tool, not only for identifying bottlenecks, but maybe doing such things as process or line design and line balancing. The next type of analysis that we have that's standard in the package is box plots. And what this will do is identify the process that has the most amount of variability. And we look at that based upon cycle after cycle and measuring step or SOP step time continuously. Ideally, with processing or with production, if you can reduce the amount of variability and have adherence to the SOP, now you have true control of your process and really have a clear picture of how your process is running. Moreover, if you look at the process that's varying the most, this allows you a chance to affect some change, maybe make some reconfigure the workstation. Maybe it's a training issue, but it really identifies what area or what particular step in an SOP needs the most attention. And last but definitely not least, we also have control charts. One of the unique features that we built into the solution was really the opportunity or the ability to go in at each step in an SOP, click on that data point, if it's say above or below our upper or lower control limit, and really take a look at what's happening. In particular cases, this can be an incident report. So you can identify, what happened at that particular case. Was the operator distracted? Did they drop a tool? We did have a circumstance where we did see process drift based upon looking at this chart, and realized that it was a problem with the part and not the operator. The parts weren't fitting. So we actually had a supplier issue. It had nothing to do with the operator itself, but we saw the process drift because they were struggling trying to get the parts to fit properly within the assembly itself. If you'll recall, I mentioned real-time inferencing and real-time motion detection. We do have this as part of the solution. This requires a local or an on-premise workstation and GPU. But with Optimo and with the software solution, we're able to essentially collect cycle time information in real time. Moreover, it also allows us to give an indicator to the operator whether they've missed a step or performed the SOP out of sequence. In certain cases, following the sequence step is very, very important. In other cases, just the fact that all steps are completed is most important. It allows you that option. But really what I want to draw your attention to here is the fact that we now can get this type of data, cycle time data and step measurements in real time. And again, this provides an invaluable tool, especially if you have a new process or you're just testing out, say a new product or a new manufacturing methodology. So in summary, for our particular application, this was the station that I've been showing as an example, where we have 5 steps in the SOP. We're tracking each of those individual steps. After training, we measure the cycle time of each of those steps, and we were able to affect an improvement with respect to that workstation and reduce the cycle time through the entire step or the entire SOP quite effectively. I think we saw 20%, 20 to 30% reduction in overall cycle time based upon the information that we were able to obtain using Optimo. Now, as you can well imagine, being a consumer electronics manufacturer and contract assembler, this works very, very well in an electronics environment, but we've also been able to apply this in other areas as well. For example, a couple of summers ago, we did a project for a tier 1 automotive supplier by the name of Minth. We basically sent an engineer on site, set up the camera, started gathering information, provided the annotation and training, and within less than 5 days, we were able to identify a 50% reduction in cycle time for just one production line. So as you can see, depending upon how your operation is performing or how it's running, ROI can be very, very quick with a tool like this. Moreover, it also gives you a chance to say, if you affect a change, see if the change that you've implemented had the net effect or the reduction in cycle time that you expected. So here's just an example. What we did is we compared operators on shift 1 and shift 2. And just to give you an idea, this isn't just one incident, this is over time. So as you can see, I'll alert you to step 7. Step 7 is non-value add, or basically where the operators were waiting for parts to shuttle into the workstation. So ignore that. But steps 3 and 4 really identify a difference in process and cycle time for that particular SOP. So as you can see, between the operator in shift 1 and shift 2 in step 3, there's almost a 4x differential. Step 4, it's almost a 2x differential. And it wasn't quite evident until you looked at the two side by side. As you can see, there's quite a bit of difference. And this really was just a result, to be fair, on to the operator on shift 2. He was new, and it was just a training issue. He struggled with basically securing the wiring harness into the rear fascia. This was on an SUV, back rear fascia on an SUV. So, yeah, in summary, that's pretty much it. I mean, with what we found is with AI video analytics, time studies can now elevate from a measurement tool to a management tool for manual process and performance improvement. I would ask, hopefully, for any of you that are here in the session, if you want to find out more information, please scan the QR code, visit our website, contact us directly. We like to talk, of course. And with that, I guess I will open it up to any questions if anybody has any.
Yes, the chat. If you want to enter a question, there's the chat button at the bottom of the window. You should be able to click on that and ask any question that you like.
Tim, can you enable the chat on the Zoom?
Is it not enabled? Chat should be enabled. It looks like the Q&A is not enabled. Questions. It all should be enabled, actually.
Okay. Okay. Well, like I said, alternatively, if we can't get that working, you have the link to our website. I think we've posted contact information. Again, we apologize for some of the technical difficulties. Zoom didn't seem to want to play with LinkedIn, so we apologize for that. But ultimately, we hope that you found at least some of this information useful and interesting. And we would absolutely love to talk about applications. Being this an emerging technology, we're always looking for new case studies and new areas with which we think that this type of solution can be applied. So please do feel free to reach out to us at any time. Happy to answer any questions. And most importantly, thank you so much for attending and taking time out of your day to dive into AI video analytics. Thank you.
Yeah, the chat is now enabled for everyone. So please, if you have comments, thank you for sticking around this long. If you have questions, please enter them into the chat. I'll turn my camera on as well. If not, I guess we will call it a meeting. Oh, there we go. From Luo, what level of accuracy and reliability can we expect from video analytics algorithms, especially in complex manufacturing floor environments?
That's a good.
Carl?
Yeah, that's a good question. Really what it comes down to is the complexity of the task, and there are, like with any tool, there are certain limitations. Like, for example, if you're building a watch, because of video analytics, it does not have the resolution to look at, say, installing a spring or a sprocket or a shaft or what have you. So accuracy, it really kind of comes down to how repeatable that process is. We had a case study earlier this year where every single time the operator performed that task, he was doing it differently, and that became a philosophical question with respect to the process engineer and the industrial engineer. Really, what we tasked them with is said, look, AI algorithms work based on recognizing patterns, and they're very, very good at doing that. If that pattern changes significantly, they do tend to have a hard time. So what we did is when we talked to this process engineer, we said, look, the key here for any tool like this to work is the process has to be executed preferably the same time every time, or very, very close. It can accommodate wide variations, but then the accuracy of the tool goes down. So if you understand kind of what I'm getting at, is this is kind of a chicken and egg sort of scenario where you want that process to be as repeatable, not only for, say, for example, ISO compliance and so forth, so that you can train another operator and so forth, but you also want the operator themselves to, execute it within the allotted cycle time. So to answer your question very succinctly, accuracy and reliability really depends on how well the operator is performing that task and how consistently they do that. Ultimately, what we want to do is we want those operators to be consistent, right? That's why you're using a tool like this, and so it can be used as a feedback loop in that respect. I hope that answers your question. Anybody else? Okay, well, again, thanks so much for attending. Hopefully you found something interesting, and please feel free, reach out. I'd love to talk to you.
Thank you, Carl, and thank you to all the attendees. And we'll definitely post this recording to LinkedIn, and it will be available through my website. I'm sure that Foxconn will make it available as well.
Sure. Okay. Thanks, everybody. Have a good day.
Thank you.